Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocket Man, and today we are talking about space-based solar power. Hey, Ben, how are you?
Space
Some
based. Everything is
space,
better space based.
space-based
Hey,
solar power. What a
hey
word!
Simon. Hey fellow Econauts. Yeah, today we want to put a light on
it's,
space based solar power.
it's a line on space-based solar power. What is space-based solar power?
Well, I guess it's very self-explanatory. The idea is around for many years already, for many decades. The idea is to capture solar light or reflect solar light from orbit to a spot on Earth where you can then collect the energy.
So how exactly does it work? How can we transfer solar energy back to Earth?
The efficiency of solar panels in space is way better than on Earth. So on Earth we get at best between 15 and 20%, I think, currently. And in space you can get up to 80% efficiency from the solar panels. So obviously that is the first thing which makes it more interesting. The second one is also that you capture more light per square meter because of our air. Luckily we have it. The air absorbs a lot of solar energy, and therefore not all the light reaches our solar panels. So therefore one important thing is you could capture the solar energy in space with the solar panels better than on Earth. Now, obviously, you have to get the energy back, as you said. So now, in that concept, you would have to to transfer the energy, for example, as electricity via a cable, which is currently not possible. Or I think one of the methods currently discussed and investigated is through microwaves. So you transfer the energy through microwaves onto a receiver, and then you can capture that. I think one important part of information here is when you send radio signals, that is also already sending energy. It's just like so minute, but we measure an electron flux, and we can make signals and information out of it. So this is more or less the same idea, just boosted. The second pathway that has been discussed a lot is to reflect sunlight from a mirror to a spot on Earth, so that you still have the solar panels on Earth, but you have now, instead of day-night cycle, you have permanent light shining on the solar panels.
Isn't
So
isn't
these
it
are the two ways.
dangerous, like a Death Star suddenly having like a big
It's not it's not quite
energy
the same
beam
thing.
coming from the space right at us? No,
Well, I
of course
mean,
I'm kidding, but you know.
I think the idea of solar energy in space has some merits, but also a lot of disadvantages, such as, okay, how do we get the energy down? I think that's the biggest thing. And also the second thing is, how do we build it up? We need to send, similar to the ISS, we have to send lots of rockets up there just to build the huge array and everything around it. So that takes years, and it's very expensive. So at the end of the day, although everybody seems to look only at the emissions currently, also the affordability for the customer is important.
Regardless if it is working for us on Earth, I still think that it's an interesting concept to have energy available in space, because at some point, and if we want to move forward and become an interplanetary species, we also need to have energy in space, right? So even if we may not be able to crack that nut, how to get the energy back to Earth, I think that's still a good idea to investigate, because it might be working sending energy to the moon because there's no atmosphere, or it might be working to have like energy available in space for any kind of space station, or
Yeah, I mean that's what they do pretty much in the moment for space stations, and also for rovers on other planets and or the moon. And as long as they have sunlight, that works. So that is a concept that's why they have these high efficiency cells. One factor to consider is, so just from Earth perspective, when you measure the energy per square meter from the sun above our atmosphere, it's about 1.3, 1.4 kilowatts. after our atmosphere, we lose about 2 to 300 watts. So it's between 1 and 1.1 kilowatts. And then on Earth, obviously, now it depends also on angle, weather, day, night, and so on. On the moon, you have a similar amount of energy reaching the moon because of the distance is very similar to the sun. But if we go to Mars, Mars is far further away. And I would have to lie, I don't know the number right now per square meter, but it is lower than on Earth. So obviously, the further away you get from the sun, the less energy you are able to capture because less photons are arriving.
Because we do have to consider all of those possibilities if we
Yes,
really
yes,
want
sir.
to, because it makes no sense, and we talked about that also in previous shows, it makes no sense to actually get the resources back on Earth. It makes much more sense to actually use the resources in
Yes.
space and then have like the final product sent to Earth, the final consumer product basically, or to
Yeah.
whatever colony,
or use it in space.
or
Yeah.
use it in space.
No,
Exactly.
100%.
But
That's exactly that's absolutely correct. And energy is also a resource. And yes, so if we harvest that resource in space, we should find ways to use it in space. Obviously, I agree on that notion.
I think it will help us a lot to also save on some problems that we may already have in our minds. So how exactly can we have like energy? How can we use our machines if we have that available in space? Then we already have like a lot of problems solved because many
Yeah.
of our equipment needs electricity, right, to actually
Absolutely, yeah.
function, right?
And as I said, like all satellites and all all stations, all space stations, all rovers in space, they work mainly with solar panels to an extent. If they don't have an RTG on that, we can talk about this in another episode. But solar panels is the bread and butter for space, really. So we need that in order to get electricity.
If we invest more money in resources to actually research better options in space, even if they are initially only thought as something that is like back, sent back to Earth. You never know what you're discovering by trying to solve one problem and you're accidentally solving another problem, right?
Yeah,
Sticky
yeah, yeah.
notes come to mind. You never know what you can discover, right?
Yeah, that's why I think space exploration and space research is so important, because I always say the universe and also our solar system is huge, and our planet, our little blue marble, is a very, very tiny speck of dust compared to that huge space around us. So if we solve things that are adaptable for more places, we will eventually find solutions that are applicable for Earth and that can help us to solve issues we have here on Earth, such as energy production.
Well, let's keep it short and simple for today. I hope you liked this episode. If you did, don't forget to leave a like and subscribe if you haven't already.
And don't forget to hit the notification bell. And also check out our other episodes.
All right. I hope I see you next time. Have a good one. Bye-bye.
Bye.